Gold is actually less subject to fluctuations in price than these other commodity metals. Although people think, oh yeah, gold prices rise and fall, they rise and fall a lot less than do these commodity metals.
This is Kaiser Johnson with Liberty and Finance, and these are the Miles Franklin Weekly Specials for December 29th, 2025 through January 5th, 2026 while supplies last. Quarter-ounce gold eagles are just $105 over melt per coin. Call and ask about our Christmas special on 90% junk silver. To order our specials or any of the many other options we have available, call us at 1-888-81-LIBERTY. That's 1-888-815-4237. We're available after hours and on weekends, and we look forward to speaking with you.
Welcome back to Liberty and Finance. I'm delighted to introduce a first-time guest here. Dr. James Tour, PhD, is I would say he almost defies definition because he's been involved in so many realms of endeavor. He caught our attention recently because of an article that came out in the Epoch Times talking about a new process for the recovery of rare materials that otherwise could cause social or geopolitical strife between nations, but now can be reclaimed from scrap materials through an innovative process. Dr. Tour, thank you for joining us here on Liberty and Finance this first time.
Oh, thank you so much. Glad to be here.
Our audience, our viewers and subscribers are keenly interested in real things. They've been following the history of several critical materials recently, and most notably there's been a lot of wrangling geopolitically over what's referred to as rare earth minerals and other critical commodities that different countries have been declaring strategically important to their countries, and that's all true. And yet you have been an innovator for decades in the fields of nanotechnology and other processes, in addition to your work in philosophy and religion and all kinds of things. But recently, having announced a commercially viable and potentially scalable at economic rates, a process for basically flash treating scrap to reclaim such materials that otherwise countries might go to war over. In fact, we heard that some generals being presented with this at the Department of Defense said something like, once they grasped the concept that you were pitching, said this could prevent wars. So, can you talk to us about this latest breakthrough in process technology and what led to it and where you see it going in the near future?
Okay, well, there were a lot of questions in there, so I'll try to answer them all. The way this started was in 2018. We discovered this process called flash Joule heating, which has actually been around for a long time, but to make new materials. And we started a company in 2019 called Universal Matter Inc., and that is based that is actually based in Toronto, interestingly enough, and they can produce 1 ton of graphene per day. Graphene being the one atomic layer sheets of carbon. Using that same sort of process, we modified it a little bit, where we introduce now chlorine into the atmosphere while we are doing the flashing. And with flashing, by this I mean, we take a material, we put it between 2 electrodes, and we apply a high voltage and a high current, and we drive a current through the material. In the case of carbon, it breaks all the carbon-carbon bonds, and then it reforms as the material graphene. In the case of what we're doing now with metals, is what we do is we take, for example, waste material, say a printed circuit board. We grind up that printed circuit board, and it's usually hard to recover all the metals in a printed circuit board because it's laminated between successive plastic layers. It's very hard to get through. But what happens is we heat this in this process, and we can heat to 3,000 degrees centigrade in less than 1 second. And we just heat it up very high, and it reacts at these high temperatures with the chlorine gas to form the metal chlorides. And to put it in perspective, if you take, for example, titanium oxide or titanium metal, both of those boil at about 3,000 degrees centigrade. But if you convert them to titanium tetrachloride, where we make the chloride of titanium, that boils now at 136 degrees centigrade. So we've lowered the temperature by almost 3,000 degrees by making the chloride. So what we can do is we can go up to the reaction temperature. We don't have to go up to 3,000. We can go up to whatever the reaction temperature is to hit the formation of the metal chloride, and then those come distilling out. So we have lots of knobs to turn of how we want to make the chloride, what is the boiling point of the chloride, and then being able to pull these out in this way, so we can remove one metal after another. And these critical metals are these metals, particularly for the United States, has deemed them critical because China is no longer selling them to the U.S. That includes the rare earth elements, but it includes much more than that. It'll include tin, antimony, germanium, gallium, indium, and tantalum. All of these metals that are critical for our electronics. They've made it very hard to secure, and not just those metals, but also things like graphite, battery-grade graphite they're withholding from us now. So we have to have a national effort to be able to access these things, and we have all these metals among us already, and it's in our waste. It's in our waste material. So rather than throwing all this onto a barge and sending it to Africa, which is what we do now, we take it and we just flash it, and these metals come back out. And the concentration of these critical metals in the waste is 1,000 times higher than what you see in the metal ores. So why not deal off the waste? Because then we have this source already for us, here with us. We don't have to go around the world mining this. We don't have to make a deal with the Ukraine to get their rare earth element, access to the rare earth element mines. We don't have to ship it here. It's already here. And so it's a win-win in many respects.
In some ways, this kind of a process leap reminds me of what's been talked about for decades since I was in junior high reading Popular Science magazine about, for example, nuclear fusion. And one of the criticisms that's often leveled against that technology is, okay, it can perhaps happen on a microscopic scale in a laboratory environment under such extreme controlled conditions and with such a consumption of energy that it'll be so far away before it's commercially viable. What are you looking at as far as a timeline that you believe is realistic to commercial scale viability for the process that you just described for reclamation of these materials from scrap materials?
Right. So because we have this proven track record with starting this company, Universal Matter, where we had learned how to scale the process, there was already some knowledge behind us in that. And so we started this company called Flash Metals USA, and that is a division of Metallium Limited, Metallium with two L's, Metallium Limited. And on the U.S. stock exchange, it's MTMCF is the ticker symbol. And so that company is in existence, and it bought a pre-licensed site, a pre-approved site, just about about an hour's drive here from the university in Houston, Texas. It's at a place called Anahuac, Texas, and it's near the Houston Ship Channel. So there's an enormous number of resources coming in and out of that area. And so that they bought 37,000 square feet facility. It was pre-permitted, which means that we did not have to secure a permit to do recycling there. It was already pre-permitted. The permit goes with the site. And so that is already pre-permitted, and that is being built up to a larger facility. That facility is being expanded out now to 90,000 square feet from 37,000 square feet. So it's being enlarged. And the equipment is already moving into that site. And so it is in January, is projected just next month, in the next few weeks, that production will start, and they will start getting gold and tin and germanium and gallium are the first four metals that they'll be isolating. And then shortly after that, the rare earth elements will start coming online. They will be dealing off of printed circuit boards. Already the offtake agreements are in place. We have agreements to secure printed circuit boards where we have guarantees that the printed circuit boards will come to us. You say, well, are there enough printed circuit boards? Do you have to go from house to house and get these from people's iPhones? And the answer is no. There are these data centers which are being built all over the United States and have been built. Every time you store something to the cloud, that is stored in a data center somewhere. Every time you take a photograph, and that is stored in a data center somewhere. If you backed up your iPhone or something, that's stored. These printed circuit boards and data centers are replaced out every 1 to 3 years. 3 years being the oldest. So there are mountains of printed circuit boards, mountains. And so that's just a matter of them being trucked in, but not in small quantities, in very large quantities. And we've already got guarantees for them to come in. And then these are shredded and then just put into the flash machine. So we project that we will be doing next month in January, so in the next few weeks, 1 ton of printed circuit boards per day. 1 ton per day, and that by September of 2026, we will be doing 20 tons per day of printed circuit boards. In addition to the printed circuit boards, we are going to be getting what are called tailings. These are the residues that are left over during mining operations that they can no longer extract things out of because there's too much of another element in there. And our methods can separate these out very quickly. And so we're going to be getting tailings coming into us, and we're also going to be setting up operations at these tailing facilities. So bringing our units, which are all skid-based, meaning that they're on these wooden platforms that can be with a forklift loaded onto a truck and shipped out to the locations where these mining operations are happening, and then the separations will go on at those mining operation facilities. We'll put up a covering. It's all these sheet metal units that are put up and installed very quickly, and these will go in there, and we bring in the electrical power, and we do this. Now, people will say, well, it must take a lot of energy to heat up to these thousands of degrees. Actually, it doesn't. It takes a lot, but for very small amounts of time, meaning that the amount of electricity that we actually use overall is very low because we use a lot all at once, and in a couple of seconds the flash is done and we no longer use anymore until the next flash. So we're not heating up a big furnace and trying to heat all these. We heat directly into the material. So to give you an idea, when we had estimated what it would cost us to make graphene, where we were heating up carbon to 3,000 degrees, we had estimated about $30 per ton in electricity costs. And these have been maintained. And the same thing is happening as we look at the flashing that's going to be needed for these printed circuit boards, because a lot of these processes are exothermic. They generate them their own heat. So once we bring them up to a certain temperature, then the decomposition of these processes, they generate their own heat. So the free energy is negative, and so they are blowing out heat in the process. So once we bring them up to a certain temperature, then they generate their own heat. So energy-wise, it's going to work out very well. In fact, the plan is, on top of our large facility in Anahuac, Texas, we will put solar panels, and we will also be capturing, when you flash these printed circuit boards, what happens is the plastic that it's made out of forms predominantly hydrogen or carbon monoxide, or both. The hydrogen and carbon monoxide can be sold as something called syngas, S-Y-N gas, which is used a lot in the chemical industry. If you have any chemists listening to that, they'll know that's a mixture of hydrogen and carbon monoxide, which is used in the hydroformylation reaction to make all sorts of plastics and chemicals, and that will be sold into the Houston Ship Channel, which is very close to our facility. where they do a lot of processing of chemicals, but also hydrogen gas is generated. And that H2 can be captured and then refunneled into the process in a fuel cell or just combusted. So we estimate that we will be able to generate about 60% of our own electricity through the solar arrays and through the gas capture.
This is there's so many parts of this that seem beneficial. One of which we've interviewed CEOs of mining companies from various metal industries for the past several years, talking about a massive metal shortage coming, talking about a structural deficit between the supply and the demand and consumption of metals. And that's even if you consider there may be a recession or whatever in some of the developed nations, that the other nations which have not yet enjoyed the kind of standard of living that the developed nations have over the past several decades, if they all want to rise to that level of standard of living with availability of things that are going to make people's lives more comfortable and safer and so on, are going to require massive amounts of a wide variety of metals. It looks like this might be one of the ways of bringing online faster, perhaps, than some of the multi-decade processes of scaling up mining operations and getting permitting and so on. And I guess part of that speed is due to the process, and part of it may be due to the environmental friendliness overall. If you look at the overall envelope of the ins and outs of your process, it sounds like maybe a lot more ecologically friendly. Any comments from you on either addressing the massive metal shortage that has been foreshadowed, or also reduce, reuse, and recycle by intercepting these things that would have been going into the waste stream?
Yes, there is going to be a massive a shortage of metals as these are required. Now, to think about it, it costs about $200 million to set up a new mining operation. That new mining operation could take 5 to 10 years to really get going. That's a long time. Now, for example, if you look at Australia, which is a mining country, they will mine these ores. These ores then are put on barges and sent to China for processing. China then processes them, and then they are sent out from China, say, to the United States to be used, say, in our fabrication facilities. So a huge amount of shipping that goes on. Here we have all the materials present. Here we are just going to reuse them. But if we need to make more and run off of mined ore material, we can certainly do that. It's just that we have to deal with a much larger volume of material because it's just not as concentrated in those ores as it is in electronic waste, or as it is in the tailings. The tailings can have very high concentrations. So this changes that dynamic as to access. As far as the secondary waste streams, we use no acid, no bases, no flocculation methods. Sometimes we'll incorporate a little bit of water, but very little. We don't have to use water. And so our secondary waste streams go almost totally away. We've done what are called the life cycle assessments, where we look at all the different chemicals that we need to go into this, all the different amounts of energy, including the shipping and all of this, from cradle to gate, meaning to the point that we are selling this. And we look at the different waste streams that we generate. We save tons. I mean, we're like 80% less on the money to do this, 80 to 90% less on the money. The time-wise, we're like 90% less on time. Waste streams in some of our processes go to near zero. In others of our processes, we're much lower than on the waste stream. So it looks good all around. The environmentalists should like this, and those who have interest in getting access to these metals will like it, and those who want to prevent wars, because we don't have to go into other places to fight for this. We have all the cobalt here that we need for batteries. We just need to recycle it. And so we've done this with batteries, both from the anode side, the graphite side, and from the cathode side, which is often cobalt, nickel, manganese. We get all of these back out on the cathode side as well. And so we have access to all of these different operations this way. And we've done it with lithium. I mean, lithium, we have a natural mineral here all over the United States called spodumene. Usually it's expensive to pull lithium out of spodumene. Spodumene is 5% lithium by weight. The other elements being aluminum and silicon, hard to get at it. Whereas these mines, these brine facilities in South America are 2% lithium by weight. Remember, the ore is, this spodumene ore is 5% lithium by weight. The lithium brines in the United States, where they go deep well drilling, is 0.25% lithium. Spodumene is 5% lithium. In a single flash, we pull the lithium right out as lithium chloride. It comes distilling right out. So in a single flash. So the whole operation changes. We don't have to do lithium mining in South America through these brines, waiting for those brines to sit out in the desert for 18 months to dry out and then go after that lithium. We have the spodumene right here. A single flash converts it from spodumene to alpha spodumene to the beta spodumene. During that same flash, the lithium chloride forms and comes distilling out. And all of this has been licensed into this company, Metallium, and the U.S. division being Flash Metals USA. And all of this is going to be done here. We already have new facilities, pre-permitted facilities we've also purchased in Massachusetts, in Ohio, and in Virginia. So these are 3 other facilities in the country that will soon be coming online to carry out this same thing. So the Texas facility is already being equipped. Like I said, in a matter of weeks, it will begin the production on a ton a day of printed circuit boards.
The implications are staggering of such technological leap like this, because back 300 to 400 years ago, it seemed that the discovery of the New World by European explorers led to a carving up of the whole globe over the next century or so from a lot of European countries. And it really starts to, they say history doesn't repeat, but it rhymes. The last several years and looking forward, it seemed like that same scramble for the puzzle pieces of the world between China, the US, and other countries, Russia, and so on, everybody taking positions about who has alliances with whom to make sure that the countries where these rare materials are to be found, make sure that they're under control of those who want to get after those materials. It's been very concerning for those hoping for peace in our world, especially as we go through the Christmas and New Year's season here, looking for a peaceful future for our world. But the idea of being able to reuse materials that you've already bought once or you've already obtained once from Mother Nature and being able to use them again and put them back to productive use is extremely exciting, especially since you're looking at scaling that up to commercial scale. Any other forward-looking direction that you want to share, that you can share with our audience about what you're focusing on next, in addition to these scale-up, ramping up of your existing process?
Yes, all of this has been precipitated because China has threatened not to sell us these elements. They did that with Japan a few years ago when they had a spat in the waterways there, and that about shut down the Japanese electronics industry if that didn't get properly addressed. But what is going to happen as a result of China applying this pressure is, I've seen this with other technologies as well. Here's what happens. A country or a people or a company makes it hard for people to access, or they raise the price so much that then what happens is innovators come in and they find new ways to get at what they need, or they find a way around it to substitute it with something else. And the original person, the original group, the original nation that has made it difficult is left out in the cold. That is what is going to happen to China. I think China has severely hurt their future by doing this. By restricting the sale, what is going to happen is innovators are going to find a way around it. China is not going to be necessary for this anymore, and their massive business in these critical metals is going to drop dramatically. And what the U.S. government has done to protect us from the artificial lowering of prices is the U.S. government has guaranteed us baseline prices. They've guaranteed us prices on these elements. So in other words, when we build out this company to start producing, China will drop their prices and try to flood the market with these elements to put us out of business, and the U.S. government will guarantee us a certain pricing for this to protect our business from these artificial fluctuations to try to drive us out of business. So that's one thing that they certainly do to us. Concerning your other question, which was things that we are going to be producing. Actually, there is a lot of gold in electronics. A lot of gold is used, and particularly in ITO and indium tin oxide displays. There's indium that we want, there's tin, but there's also a lot of gold in those. Sometimes we've even found that there's more gold in indium tin oxide displays than there is indium. And so we can go after the gold, and we have been offered to sell this gold to a particular jewelry company, which is going to have a whole new line of gold jewelry where the gold has been reclaimed from waste, because there's a market for this, because there's people that don't want to be buying gold jewelry because they don't like that there's this degrading mining going on. Both people being abused by the processes of these minings, but also in gold, a lot of cyanide is used, and you have these secondary waste streams, and all of this will be recovered without any cyanide usage, with very little to no water usage, with no acids, with no bases, and no going to these mines, no stripping the earth for this. This is already in our hands, and it will be reclaimed and then go right back into gold jewelry. So that will be actually the first thing that the company starts producing is gold, because gold is actually less subject to fluctuations in price than these other commodity metals. Although people think, oh yeah, gold prices rise and fall. They rise and fall a lot less than do these commodity metals. And so that will be one of our selling points, which will bring stability to the company, because gold is always going to be in demand.
And one of the criticisms that would be levied against this utopian view you painted just there is the continued inputs of energy into the process, and yet you've also explained that the process itself liberates some forms of fuel that can be used to offset that by at least like 60%. So it's an exciting time. It's an exciting kind of a breakthrough that would be of high interest to all those who are truly interested in making sure that people get what they need from the earth and do it in a way that's the most responsible and most conducive both with the health of the environment, the health of the economic health of the companies and the countries involved, as well as geopolitical peace. Exciting breakthrough. Dr. James Tour, for people who want to follow up and correspond with you and your organization, where should they get connected?
Okay, my social media is Dr. James Tour on all the different platforms. So just Dr. James Tour, and then my website is jmtour.com is my professional website. I'm at Rice University, so you could track me down through Rice University's website as well.
Well, we're grateful for your presence here with us this first time on Liberty and Finance. This is a very exciting breakthrough, and it proves to show a lot of promise for the future. We'd like to stay in touch with you as things move forward, because it sounds like we're on a fast track to demonstrating some rather remarkable accomplishments even in the next quarter. So grateful for your presence here this first time with us on Liberty and Finance.
Thank you.
This is Kaiser Johnson with Liberty and Finance, and these are the Miles Franklin Weekly Specials for December 29th, 2025 through January 5th, 2026 while supplies last. Quarter-ounce gold eagles are just $105 over melt per coin. Call and ask about our Christmas special on 90% junk silver. To order our specials or any of the many other options we have available, call us at 1-888-81-LIBERTY. That's 1-888-815-4237. We're available after hours and on weekends, and we look forward to speaking with you.